Hello everyone, good afternoon. Today I am going to discuss a problem that is based on the material balance in roasting of copper ore. So the problem is the roasting of 100 gram of a copper ore yielded 71.8 gram of pure copper if the ore is composed of Cu2s and CuS, that is copper 1 sulfide and copper 2 sulfide with 4.5% inert impurity. Calculate the percentage or the percent of Cu2s in the ore. So basically you can see here we have 100 gram total sample, and in 100 gram there is CO2s as well as CO2O as well as CuS, not CO2O, this is CuS, as well as there are 4.5% inert impurities, that is how much, 4.5 grams, because total is 100 gram. Now in CO2s and CuS we don't know the exact amount of CO2s and CuS out of 100 gram, so let this is x gram, then this will be how much, 100 minus x minus 4.5 gram, or you can say this is 95.5 minus x gram. So this is the amount of CO2s and this is the amount of CuS in the sample. Okay, now let's see the roasting of Cu2s. The given equation or the reaction that will take place is Cu2s plus O2 will react and it will form Cu plus SO2. Now this is not balanced, so just copper is 2 here, so you balance here 2, sulfur is 1, O2 is, now it is balanced. Similarly CuS will also react with oxygen during the roasting and it will form Cu plus SO2. Now copper is 1 here, sulfur 1, oxygen 2, it is already balanced. Now we apply the mole concept, that we can write mass of copper from Cu2s plus mass of copper from CuS will be equal to how much, 71.8 gram, because it is given at 71.8 gram of pure copper is produced. So in this sum of the amount of copper is produced, in this case also sum of the amount of copper is produced, and if we add both of the masses we will get 71.8 gram. Now how much copper will be produced from the first reaction, that is from this reaction? So it is x gram, we have lettered it x gram, then its mole will be x divided by 159, because the molecular mass of this Cu2s is 159. So if you apply the mole concept, coefficient of Cu2s is 1 and coefficient of copper is 2, so we can say 1 mole of Cu2s will give 2 mole of copper, so this much mole will give you 2x divided by 159 moles of copper. Okay, similarly for this CuS is 95.5 minus x gram. If you convert into mole, then it is 95.5. Cu2s, the molecular mass is 95.5. Now when we apply mole concept, 1 mole will give 1, because the coefficient is 1 and 1 for both CuS and copper. So we are getting here 95.5 minus x divided by 95.5 mole. Now mass of copper from Cu2s is this much mole, 2x by 159. This is the mole of copper, but we know that 63.3 is the gram atomic mass of the copper. So this is the total mass of the copper that is obtained here. Similarly, the total moles of the copper obtained in the second reaction is 95.5 minus x divided by 95.5 into the mass of the CO2 is again 60, sorry, it is not 63.3, this is 63.5, again here 63.5. That is the gram atomic mass of copper. Generally it is around 63.5, and this will together will give you 71.8 gram. Now next, what you have to do, you have to simply solve this, and you have to solve it for x. Okay, so if you solve it, you will get x into, multiply these two, so 127 by 159 minus, if you solve this, you will get 63.5 divided by 95.5, and it will be equal to, when you multiply this by 63.5, you will get what, 8.3. Okay, so if you will solve it, you will get this much. Okay, now because there is 95.5 into 63.5 by this, you have to subtract it from here, and you will get this much. So basically you have to solve this simple linear equation. This is calculative, so you have to use the scientific calculator here, and when you got x, the x will be equal to 62.01. so that is 62.01 gram, because x is the mass of CO2s in the 100 gram sample. So mass percentage of CO2s in the sample is again 62%, because the total mass is 100 grams, so we can say 62 gram into 100 divided by 100, again you are getting the 62%. Thank you.